Now this time around we will be attempting, and I mean attempting, to iodinate fluorescent. It's usually supplied as its sodium salt. So I'm going to proceed and add 1 gram of fluorescent powder in this beaker. .84 grams of iodine and 20 milliliters of glacial acetic acid, which will be our solvent, and start stirring. Now, as a catalyst, I will slowly, and I mean slowly, add 5 milliliters of 30% hydrogen peroxide. And as you can see, I am washing any remaining fluorescent from the walls of the beaker. And I need to add that if we get any product, it will be visible as the fluorescence will change from green to a different color. So I'm going to leave this run for quite some time and apply some heating. And we'll see what happens. Now it's very possible we end up with a black goo or some kind of tar-like product, because hydrogen peroxide isn't so gentle on organic substances, so that's always the case, especially when you involve a halogen, even if that halogen is iodine, which is a gentle halogen. Still, we have very oxidizing conditions in there. We have glacial acetic acid, we have hydrogen peroxide and iodine, so you never know. But if we do iodinate the fluorescent, whether we get crystals or not, that's another thing. We will be able to tell due to the change in fluorescence, the shift in color. And I've added way too much fluorescent in there for us to observe the change in color. A tiny drop of this solution, even in half a liter of water, will fluoresce strongly in the green spectrum, as is now, before the reaction, if a reaction does take place, that is. And so, yeah, we will see as time goes on what will happen. For now, all I can see is that I'm losing some iodine as vapor, which is not good. But yeah, you never know. So this is the fluorescein after iodination, which has surprisingly worked. And now if I bring my UV torch near the fluorescein, you won't see it on camera, but its fluorescence has changed from a deep green to a yellowish red, which is the color of iodinated fluorescein. And I'm gonna take a sample now and show it in solution for you guys. So now I am heating the crystals in order for them to redissolve in the solution to make a recrystallization. But until that happens, I'm gonna take a sample and dilute it in this beaker, and then I will take my UV torch and I'm gonna shine a light through it. And as you can see, this is not the color of a fluorescein. This is the color of iodinated fluorescein, which is fucking awesome. Yay! I mean, it's yellow, but it's the good kind of yellow, you know? It's the kind of yellow that's fine, you know? So here's the precipitated fluorescein, the iodinated precipitated fluorescein. Now I'm gonna do filtration and collect the crystals. And yeah, here are the two dyes. This is normal fluorescein. This is iodinated fluorescein. One glows green, the other one glows orange or red. So yeah, iodinated fluorescein, normal fluorescein. I don't know, maybe there are also some other kind of byproducts in there. Actually, I'm 100% sure that there are more than one compounds mixed in there, probably some partially halogenated analogues of fluorescein, some more or less iodinated ones, but yeah, it's quite clear that the emission spectrum has shifted towards red quite a bit, from 555 nanometers to about 600 nanometers. So yeah, that's what I wanted to share with you guys. I hope you found it interesting. Hope you learned something. And yeah, keep exploring, keep dreaming, and I will see you on the next one.